Hello, calculus students and general seekers of truth. Welcome to the third part here on Taylor series, and this time we are going to talk about error bounds. And before we dive into the error bounds, let's just look at this warm-up question because it will be related to some other stuff that we do later on. What is the limit as n approaches infinity of 100 to the nth divided by n factorial? So another way that this question can be phrased is, which function grows faster, the exponential function or the factorial function? So to gain a little bit of insight to this, we could list out some of the terms. So 100 to the nth is nothing more than 100 times 100 times 100. You get the idea. Dot, 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 times 100, times another 100, dot, 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 so on, forward until whenever we reach n hundreds. Okay. Now let's compare that to n factorial. N factorial is 1 times 2 times 3 times 4, dot, 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 dot. Eventually we'll get to 100, and then we'll get 101 onwards until whenever, however large the value of n is. Okay. So let's think about which function is larger. Okay. Now, from from the first term all the way to the 100th term, from in this block right here, 100th to the nth is larger than n factorial. Okay. We can see that's clearly true because in the first case you're multiplying by a bunch of hundreds, and in the second case you're multiplying by 1 and 2 and 3 and 4. And up to here, that much is true. But in the second half here, from 101 onwards, 100th to the nth is vastly inferior to n factorial. So depending on what value of n that we stop at, the exponential may be larger than the factorial, or if the value of n is large, the factorial is larger than the exponential. But we're taking the limit here as n approaches infinity. So this means that n can be ridiculously large. N could go all the way up to 10 billionth to the 10 billionth. So as n goes towards infinity, no matter what value you have here as the base, the factorial function will dwarf or will dominate the exponential function. So as n approaches infinity, n factorial will grow faster than 100 to the nth. Therefore, the limit as n approaches infinity of 100 to the nth over n factorial will be equal to 0. Okay? And we can also take this a step further and say that in general, in the general case, the limit as n approaches infinity of b to the n over n factorial will equal 0 for any constant b. Okay, so it really doesn't matter what the base is. We can sort of repeat this process here over and over again for whatever the base may be. The point is that there's a certain spot where the exponential will no longer be larger than the factorial. The factorial in the long run will simply explode compared to the exponential, no matter what the base is. Okay. So there we go. Nice little warm-up problem here dealing with limits. And this is also a nice metaphor for what we're about to do in the rest of the lesson. We aren't really going to prove anything rigorously, but we are going to try and reason and expand some terms and condense some terms and just really develop a logic or an intuition for everything, even if we're not going to rigorously prove anything. Okay, so this right here, it's not a proof, but hopefully the reasoning is clear and solid for you.